In this video, we want to find the product and quotient of these two complex numbers, but we're asked to leave our answer in polar form. So these are given to us in rectangular form, and if we were to multiply them in rectangular form, it would actually be probably a little more difficult to then change them into polar form, because the values of theta that we would get as a result wouldn't be nice values that we know from the unit circle. So we're going to first change each of these into polar form and then do their product using the polar form. So first let's change z. So we know that if I were to plot this complex number, it would be in quadrant 4. So this is in quadrant 4. Finding the value of r is just the square root of x squared plus y squared. So 1 squared plus negative rad 3 squared. 1 squared is 1, negative rad 3 squared is 3. So that's 1 plus 3. The square root of 4 is just 2. So we have that r is 2. And so we're looking for an angle in quadrant 4. So theta. An angle in quadrant 4 whose tangent is negative rad 3 over 1. So the tangent of theta is equal to negative rad 3 over 1. So we're looking for an angle in the fourth quadrant. So again, remember we're looking for quadrant 4. This angle is going to be 5 pi over 3 or 300 degrees. I'm going to use degrees because it actually makes our sum and difference a little easier. We don't have to worry about common denominators. And it doesn't specify here, so I can do whatever I want. So let's write this. So z is just r, which is 2, times the cosine of 300 degrees plus I times the sine of 300 degrees. So this is the value of z. Let's change w into polar form. So if I were to plot w, this would be in quadrant 1. So r for w is equal to the square root of 4 squared plus 4 squared. So that's 16 plus 16, or the square root of 32. The square root of 32, which simplifies to be 4 rad 2. So that's r. And then theta, we're looking for the tangent of some angle in which we get 4 divided by 4, or 1. So what angle in quadrant 1, so again, remember we're in quadrant 1, is going to give us a tangent of 1? Well, that would be theta equaling pi over 4, or 45 degrees. So that means that w in polar form is going to be 4 rad 2 times the cosine of 45 degrees plus I times the sine of 45 degrees. So I'm actually going to erase all of this other work, and so that we can have room to actually do our product and sum. So get rid of all of this. This is going to go away. This is going to go away, and we need to move these so that we can do this. So here's z expressed in polar form and w expressed in polar form. So now let's actually do these products. So the product of z and w, so z times w, is equal to, so 2 times 4 rad 2, 2 times 4 rad 2, all of this times the cosine of 300 plus 45 degrees plus I sine of 300 plus 40 degrees. 300 plus 45 degrees. So this turns out to be 8 rad 2, 8 rad 2 times the cosine of 345 degrees plus I sine 345 degrees. So this is the product of z and w, and now let's find the quotient. So z divided by w. So this is going to be 2 divided by 4 rad 2 times the cosine of 300 degrees minus 45 degrees plus I times the sine of 300 degrees minus 45 degrees. So 300 minus 45, that's going to be 255 degrees. And then we're going to have to kind of rationalize here. This turns out to be 1 divided by 2 rad 2 So if we rationalize this, it turns out to be the square root of 2 over 4. So the square root of 2 over 4 times the cosine of, what did we say that was, 255 degrees, plus I times the sine of 255 degrees. So this is the quotient of z and w.